Welcome back. In this lecture, we are going to take the aggregated Shapley values, what we produced at the end of the previous lesson, and we're going to do a visualization. We are going to be able to actually break down each cluster into all of these components, all of the features, and show you which ones are most important for each cluster. So it's going to give you a better understanding for how, based on the bottom-up method of aggregated values, how the model was created in terms of which features were most important for each cluster. So this will be a quick one. There's, because a lot of the code's done for us. First thing we need to do, though, is we need to code out a function, because the way that the graphing is going to take it in the graph, the built-in graphing function in the Shapley library has to take the Shapley values as a list. So we're just going to create a very quick function here that will extract the Shapley values as a list. So we need to supply the Shap values and the model. Okay, we need to supply both here. So the way we do this is we're just going to create an empty list, call it Shap as list, like this. And then what we're going to do is create a little loop, which is based on the length of all of the clusters that we find inside the model. So length model dot classes. So remember, the model is that M that we did above. Yeah. So for I, we're going to loop through all of the clusters. We know we have 4, but sometimes you might have more. And then we're just going to append to this list all of the features that are there. And then you just append the Shap values, which we know because we have the names already. And we put this in like this. Okay, this is how you do it. This is going to cycle and go through all of them and extract all the Shapley values. And at the same time, it's going to, we need the coefficients, and that's why the Shap values here, we're going to get the coefficients, and that's really what we're extracting. It is the coefficients, and they're going to get stored in this list. You could always view the list to see what it looks like, but this is the function. This is all you need. And then we just return it. Then the rest is all built into the Shapley library. So that's it. There's your function. Now we can add another code cell below. And now all we need to do here is, 1, convert everything to that list. So we run the Shap as list. Shap, we'll call it Shap as list. And then we're going to put the Shapley values to list. And we're going to supply the Shap values. This is again from the aggregated one that we did before. So those are the Shapley values that we're using here. So it is the aggregated. And then we supply the model. Once you do this, you can now do a Shap summary plot. And there's many more visualizations that are built into the, it's Shap dot summary plot. There are many more visualizations that are built into the Shapley library. And you can explore with them. Some of them will take most of them will take the aggregated Shapley values. That's usually how we usually express things through the aggregated, how well it does at explaining the model. Okay, that's usually how Shapley values are used. How well does it do at explaining the model? Or how was the model created? You can use cluster-based, and we'll go through in the summary lecture here how you could use both approaches, both the cluster-based and the aggregated. But for the most part, most of this stuff is always going to use the aggregated. Okay, so what we need to supply here is you need to supply the features data frame. You need to supply the Shap as list. So we got to extract the values. Then we got to provide the feature data frame, which is the feature matrix scaled of just the variables. And then we just tell it what kind of plot type we want. Plot type equals bar. That's it. This is all you need to do, so that when you run this, sorry, I forgot to execute the cell here. So when you run this, now you're going to get this beautiful graph telling you what's going on here. So if you can see, let's just take class 0. We know class 0 is arc. We can see we've got downside deviation and standard deviation, which are the highest ones, okay? And then you get a little bit from Sharpe ratio and a little bit from, I guess, the C-var and the maximum drawdown look kind of the same. So, but the point being here is that you have a great view of which factors are responsible for that cluster. So cluster 3, the defensive one, you see returns don't matter at all, Sharpe ratios don't matter at all, and the downside deviation doesn't matter. It's just really the fact that it's probably, if we examine it, you're going to see that the maximum drawdowns, the Sortino ratios, they're probably very good at telling you that these things know how to protect on the downside. So what you can do here is really get a sense, okay, I know that right now, if class 3 or cluster 3 is my defensive sector, well, okay, again, if you're looking for things to maximize, I want the lowest standard deviation, I want the lowest kind of risk, well, then you know that class 3 is going to be it. Because it's telling you right now, you could look at these metrics and it'll probably show you that these are the lowest risk. And that's why they've all been grouped together. Okay, so that's really it for this lecture. All right, nice and short. The whole point is just to introduce a visualization and how you can use the Shapley values. All right, in this case, it's telling you why the clusters were created in every way, what features were responsible for creating the clusters, and now using the aggregated method, you can get a beautiful visualization showing you the feature, sorry, I've been using factor and feature interchangeably. You'll have to forgive me for that. But when I say it right now, factors and features, I mean the same thing. So the features here, you can see which ones are most emphasized in terms of getting the groupings done for the clusters. All right, so very powerful one. And that's why when you look at, let's say, the technology, which I believe was class 1, I have to scroll back up to remember, I apologize. Yeah, so the technology is the green. So if we look at even the class 1, which in this case is red, different color, so we can see that the returns, and the Sharpe ratios. So I would, my inference here is that they've just done so well and also have done well on a risk-reward basis that even if they have a higher standard deviation or a higher CVAR or something, it doesn't matter because you've been rewarded for it. That's how I'm going to interpret this thing over here, seeing that the red is much bigger for return and Sharpe ratio. All right, we're going to end the lecture there. In the last lecture of the summary, we're going to start going through a lot of the interpretation and how we can use the cluster-based and how we can use the aggregated. And all of those notes will be found in the notebook. Thank you.